Today we are going to learn about harvest and yield estimation. We're going to learn about yield calculations, pre-harvest estimation of yield, and moisture determination and drying time of seeds. Why should we predict yield? Predicting yield can be an important way to diagnose problem areas in a field if yields vary significantly across the field. It is also important for contract sales that happen before the crop is harvested to know how much yield will actually be available to sell and ensuring you have adequate storage area once harvest begins. Let's begin with a problem. You bale alfalfa hay and get 20 bales weighing an average of 40 pounds each from a 25-foot swath that is 385 feet long. What is your hay yield in tons per acre? First, let's start with the definition of a swath. A swath of hay is the amount of hay cut by one pass of the mower, while a windrow is a mound of hay formed by a windrower to allow for easier baling. In this problem, we are asked to find the total tons per acre. The easiest way to calculate this is to split it up into two sections. First, let's find our total tonnage. There are two ways to approach this problem. The first way is the picket fence method, which is used to convert units. You might have used this method previously in a chemistry class. To set up this method, first, make a fence. This is just a horizontal line with a vertical line indicating the first section. On top of the first section of the fence, put what you were first given in the equation, in this case, 20 bales. In the next section, we will add that each bale is 40 pounds each. Since we are converting from bales to pounds, pounds need to go on top. On bottom, we will have one bale. So 40 pounds is equal to one bale. If you remember in algebra, if something on the top equals something on the bottom, those cancel out. In our case, the bale on the top of our equation will cancel out with the bale on the bottom of our equation. If we skip to the end of the equation, we see that we want our hay yield to be in tons. Right now, on our fence, we have pounds as our ending unit. So we need to add one more fence section to convert pounds into tons. Like before, we will add what we are converting on top of the fence, 1 ton. Below, we put what 1 ton is equal to in pounds, or 2,000 pounds. Our pounds will now cancel each other out, and we are left with tons as our only unit. To compute this picket fence, multiply the numbers on top and divide the numbers on the bottom of the fence. 20 times 40 divided by 2,000. Our total tonnage is 0.4 tons. The other method to get total tonnage involves the same process. We will just not use the picket fence. Multiply our 20 bales by 40 pounds each to get 800 total pounds. Divide 800 pounds by 2,000 pounds to get 0.4 tons. Finally, let's figure out the area that we are getting this tonnage from and convert that into acres. Our swath is 25 feet by 385 feet. If we remember from geometry class, the area of a rectangle is length times width. So in our case, 385 feet by 25 feet equals 9,625 square feet. Remember, 1 acre equals 43,560 square feet. If we convert that into acres, we will divide by 43,560 square feet to get an area of 0.2 acres. So our yield is 0.4 tons derived from 0.2 acres. Unfortunately, we still need to do one more step because most yield is given in tons per 1 acre. To do this, we will set up a ratio. 0.4 tons over 0.2 acres equals T tons over 1 acre. We will cross multiply to get 0.4 equals 0.2 T. T is equal to 0.4 divided by 0.2, which is equal to 2. So our final answer is 2 tons per acre. Let's try another problem. You are predicting corn yield. In 30-inch rows, you pick 47 ears from a 15-foot length of row. Each ear averages 14 rows around, and each row has an average length of 33 kernels. If this hybrid averages 85,000 kernels per bushel, how many bushels per acre are in your cornfield? This problem has a lot of parts to it. Let's break it down. We need to end in bushels per acre. Let's start with calculating bushels. To do this, we need our number of ears, the number of kernels per ear, and the weight of the kernels. Let's start with the picket fence method again to determine the number of bushels. Make your fence and put 47 ears on the top of your first fence section. In the next section, we know we need ears on the bottom to cancel out with ears on the top. Let's figure out how many kernels we have per ear. There's an average of 14 rows of kernels around each ear, and each of these rows is an average of 33 kernels long. So 14 rows by 33 kernels gives us a total of 462 kernels per ear. Let's plug that back into our picket fence. 462 kernels for one ear, and our ears will cancel out. We know the top of our final picket needs to be in bushels because that is our ending unit. So let's add one more section to our fence. 1 bushel is equal to 85,000 kernels. Our kernels will cancel out and we're left with bushels, just like we wanted. Multiply the top numbers and divide the bottom numbers. 47 times 462 divided by 85,000 gives us a total of 0.25 bushels. Now let's use our other method. 47 ears times 462 kernels per ear gives us a total of 21,714 total kernels. 21,714 kernels divided by 85,000 kernels equals 0.25 bushels, which is the same answer we got from our picket fence method. Finally, let's calculate the area we picked these ears from. Our corn rows are 30 inches apart, and we only walked 15 feet into our row to pick our ears. Our corn plants are 30 inches apart, so our width from the middle of the row to the middle of the row will be 30 inches. We measure from the middle of the row to the middle of the row to ensure that we are only counting one row of corn, with 15 inches on either side of it. Our length we harvested from is 15 feet. If we add more lines, this makes a rectangle. Let's try using that to find our area. First, we must convert our width to feet so we have consistent units. There are 12 inches and 1 foot, so we divide 30 by 12 to get 2.5 feet. Our length is given as 15 feet, and if you remember from geometry, to find the area of a rectangle, we multiply length times width. So our length is 15 feet and our width is 2.5 feet. 15 times 2.5 equals 37.5 square feet. Something that you should remember in agronomy, 1 acre equals 43,560 square feet. So to convert our area of 37.5 square feet, we divide 37.5 by 43,560 square feet to get 0.00086 acres. Like we said before, we want our yield to be over 1 acre. So let's set up a ratio again to get us to bushels per 1 acre. 0.25 bushels over 0.0086 acres equals B bushels over 1 acre. Cross multiply, and 0.25 equals 0.0086 B. B equals 0.25 divided by 0.0086 to give us 290.7 bushels per acre. Corn grain dries at an average rate of 0.75% moisture loss per day from physiological maturity, or black layer, until it reaches 25% moisture. Once it reaches 25%, it loses moisture at 0.5% per day. If corn grain is 37% moisture at black layer, how many days will it be until you can combine the grain at 17% moisture? Let's divide this problem into 2 smaller problems. First, how long will it take to get to 25% moisture at a drying rate of 0.75% moisture loss per day? One way we can do this is to set up a number line. We can subtract 0.75% moisture loss per day and keep going along until we get to 25%, or 16 days later. However, this is a tedious way. An easier way to do this is that we know that 37% minus 25% equals 12% moisture. Every day we lose 0.75% moisture, or 0.75. 12 divided by 0.75 equals 16 days. Now we are at 25% moisture and need to get down to 17% moisture so that we can combine our field. There's 8% moisture that we need to lose. Every day we lose 0.5% moisture, so 8 divided by half, or 0.5, equals 16 days. If we add these 2 times together, 16 days plus 16 days, it would give us a total of 32 days that we need to wait before we can combine our grain. You harvested an 11-acre field of corn at 19% moisture, which yielded 116,400 pounds of grain. What is your yield in bushels per acre when the moisture is adjusted to 15.5%? For this problem, we will use the grain moisture conversion formula. Final mass equals initial mass times 1 minus initial moisture content over 1 minus final moisture content. Let's plug our numbers into the equation first. We know our initial mass is 116,400 pounds. Our initial moisture is 19% or 0.19, and our final moisture is 15.5% or 0.155. 1 minus 0.19 is 0.81. 1 minus 0.155 equals 0.845. 116,400 times 0.81 equals 94,284. Divided by 0.845 equals 111,578.7 pounds for our final mass. Let's convert our pounds into bushels. 1 bushel of corn equals 56 pounds. So we take our 111,578.7 pounds and divide that by 56 pounds per bushel to get a total of 1,992.5 bushels. This number seems really high, right? Remember, this was out of 11 acres, and we only want bushels per 1 acre. So let's set up a ratio. We cross multiply. 1,992.5 equals 11b, and then we divide 1,992.5 by 11 to get a total of 181.1 bushels per acre.